Good day, everyone. We are looking at how to calculate center of gravity in mathematics 6. This problem says we calculate the point of intersection of y equal to 2x plus 6 and y equal to 9 minus x squared. So I'll quickly put them down. You can see I've underlined what is important to me in that question up to so far. So I need the point of intersection of those two. Then I'll make a neat sketch of the two graphs and show the strip that you will use to calculate the volume of the solid generated when the area bounded by the graphs is rotated about the x-axis. You see, I've also underlined rotated and x-axis because the x-axis rotation is supposed to tell you how your formula for volume begins. So the strip in the diagram will tell you how it ends. So from there, we'll calculate the volume in the B part and C, sorry, the volume in the A part, then in C, we'll calculate the volume moment about the y-axis and the x-coordinate of the center of gravity. So let's start. We have to substitute equation 1 into 2. If that is done, then it means we'll be having 2x plus 6 is equal to 9 minus x squared. So that takes me to a quadratic. For me to start solving, I must make sure I see 0 on one side. So I'm taking everything to the left to make the square turn positive. So I'll get x squared plus 2x, since 2x did not move. If 9 moves, 6 minus 9 will be negative 3 is equal to 0. So I will always advise students to solve this quadratic using the quadratic formula, even though I will do it with factorization. But I really I doubt whether every student trying factorization will win. So that is why I will recommend you using the quadratic formula. So factorization, those are my factors, because if I multiply this, I will get x squared minus x plus 3x, which will give me that at minus 3. So I'm sure that I did it correctly. So if we solve, we'll get x equal to negative 3 or x equal to 1. That is, if we equate each factor to 0. Then now to get point of intersection, we must substitute these x values into the original equations. If we substitute x equal to negative 3, negative 3 squared is a 9, so 9 minus 9 is a 0. If we substitute x equal to 1, we get an 8. We still have done it in the first one, and use the same thing. So from here, my point of intersection are negative 3, 0, and 1, 8. So I can now start sketching my graph. So to sketch my graph, if I've got points of intersection, there should be a starting point because they will guide you. So this point of intersection, if I'm interpreting them, the second one here, all values are positive, so this is the first quadrant. But that one, x value is negative, so I'm in the second quadrant. And negative 3 is far away from 0 and 1, so it means the graph is more to the second quadrant. So I can design my xy plane. So that's my x and y. So you see I've left more space on the left because I'm seeing a negative 3. So those are my points. Then this side, I only need a 1, since my x values are from negative 3 to 1. Then for the y values, they are from 0 to 8. That's above the x-axis. So this can be 2, 4, 6, 8, 10. So those are that is my y-axis. And now I can plot my point. So I need the point negative 3, 0, which falls on the x-axis. Then 1, 8 will fall on at this point. So I've succeeded to plot my 2 point. So looking at the 2 point, I can now start plotting. If I check my graphs, number 1 is in the form y equal to mx plus c. So that's the standard equation of a straight line. To sketch a straight line, all you need are just 2 points. I've got 2 points plotted already, so that's enough. I can sketch a straight line, which is taking me there. So that is my straight line that I've sketched. Now it's time to do the parabola. So the parabola must also pass through the point of intersection. So from the properties of the parabola, we see that your A is negative, so expect what most students like calling a sad face to pass through the 2 points, but sketching a parabola, 2 points can never be enough for you to get the exact stuff. So if I get my parabola like this, one option is to calculate the axis of symmetry, which helps you with the turning point. So the formula is negative b on 2a. In this parabola, our b is the middle to the x, the portion of x which is not there. So this creates a 0. Then if you substitute 0 in there, you see that your y is 9. Or better, I've just said let x be 0, you will see your y. So it means that the point 0, 9 is our turning point. So 9 should be somewhere there. So that is another point where the graph must pass. So if I'm sketching my parabola, it will turn at 9, 0, and then pass through the other point of intersection. So basically, I've seen the shape of my graph, the shape of my parabola, and I've picked the region between the two graphs that I'm supposed to shade. So I'm shading this portion between the two graphs. And after shading, I have to now put a strip in the shaded portion, which is another thing that makes us to really understand how do we put a strip in a shaded region. So when I'm putting a strip in the shaded region, I need to check which kind of strip is the best. And the information we know is that a strip must touch two graphs all the time. So if I go for a vertical, whether I put it at this end, or I put it at the center, or at the right, I keep on touching the same two graphs. So this is an indication that the vertical strip should be the best. But if you were to try the horizontal, down here you are winning, but once you get up towards the end point of turning point, you see that they are touching the same graph, which shows that the horizontal strip is not an ideal one. So settle for a vertical strip. So if I get my vertical strip, I need to extend it out of the shaded portion. It takes me to the x-axis. You see I put dx there, which is a reminder of how all the formulas I were using here are supposed to end. So all the formulas here, they must end with dx. So this shows to me that all the formulas that I will use in calculation under this diagram must end with dx. So for example, we were told in the B part to calculate the volume. You know that the axis of rotation tells us how the formula for volume starts. Then my strip is touching the x-axis, tells me how my formula ends. So that is it. So if I were as an N6 student to pick the formula, I'll just go to page 5 of my formula sheet and look for that formula that starts with Vx and ends with dx. So such a formula is on page 5 of the formula sheet. You pick something like this: pi, the integral from a to b, y1 squared minus y2 squared. So once I get my formula like this with y1 and y2, it's reminding me that on my diagram there is a vertical strip. y1 is supposed to be the graph above the strip, y2 the one below the strip. So the graph above the strip happens to be my parabola. So that's my first graph. Below the strip is my straight line, which is 2x plus 6. So those are my graphs, x1, y1, and y2. So I'm done with the A part, so I can now concentrate on the volume. So to do the volume, since I'm seeing my y1 and y2, I just copy and paste. My y1, as I've indicated, is 9 minus x squared. I have to square this. My y2 is 2x plus 6. That is the graph passing below the strip. Then dx. Then my a and b, I must bring them from the x-axis. So I'll go to the x-axis. Since the formula ends with dx, I check where I started shading on the x-axis. It's from -3 to 1. So if my formula was ending with dy, then I will bring it from 0 maybe to 9 up there. So my limits are from -3 to 1. Then it's now time to start expanding from from negative 3 to 1 if I'm expanding 9 minus x squared. I've always explained to my students that the fastest way to do this kind of expansion is to take 9, you square it, it will give you 81. If you take negative x squared, you also square it, it will give you positive x to the power 4. Then the middle term, you simply take the power 2 times 9, that gives you 18, then times negative x, so you get negative 18x squared. So that's how fast you can do this kind of expansions. So if I come back to my problem, I'll be having 81 minus 18x squared plus x to the power 4. Then the second one, I'll follow the same technique. I'll take 2x and square it, gives me 4x squared. Then I'll take 6 and square it, that gives me 36. Then in the middle, I'll take 2 times 2x, that is 4x times 6, it gives me plus 24x. So that is how simple it is to expand as an NC student. So I can now pull like terms together inside the bracket. So I'll take 81 minus 36. If I take 81 minus 36, that gives me 45. Then the term in x is alone, there's no other term in x, so it will be negative 24x. Then x squared, you get negative 18x squared minus 4x squared is negative 22x squared. Then the term in x to the power 4 is also alone. Then I can now do my integration. So my integration will be 45x minus 12x squared. Since when you integrate x, you get x squared over 2. 24 over 2 is 12. Then minus 22 over 3x cubed plus 1 over 5, x to the power 5 from negative 3 to 1. Then I can now substitute my limit. The upper limit is 1. If you put 1 in there, you will get a 45 minus 12 minus 22 on 3 plus 1 over 5. Then you go to the lower limit, which is a negative 3. You get 45 times negative 3 minus 12 into negative 3 squared minus 22 and 3 into negative 3 cubed plus 1 over 5 into negative 3 to the power 5. So that is the substitution of my upper limit as well as my lower limit. So all you need to do is put this in your calculator, then you will see your answer. So I've done that already, and my answer is 1792 over 15 pi unit cube. So if you want to put it in decimals, it's fine, you can do that, but you are free to leave your answer in terms of pi if you want. So this is how easy it is to get the volume. So we can now go to the last part, the C part, said we should calculate the volume moment about the y-axis as well as the x alternate opposite. So that is what we'll be doing in the C part. So if you need the volume moment about the y-axis as an NC student, you go to page 5 of your formula sheet. The volume moment about y-axis is defined on page 5 as r dv from A to B. Then that is the formula for volume moment. So you have to develop this formula using your diagram as well as your formula. So what I will simply do here is my dv must always correspond to the formula I used for my volume. So the formula I used for my volume was the disk method, where we took our pi, the integral from A to B, y1 squared minus y2 squared. So I have to copy everything out. The integral from A to B, I will leave space there for r. Then I put my y1 squared minus y2 squared dx. Then what else do I need? I need my R. So to do my R, I need to go back to my diagram. And when I go to my diagram, this axis Y is very, very important. I must start from the center of my strip, then I move to the Y axis. So that is what we are going to do on our graph. So I'm moving back to the graph. I have to start from the center of the strip on our graph. Then we move in a straight line to the y-axis. So you see at the center of my strip, I'm moving in a straight line to the y-axis. So as I move in a straight line, you see that that dotted line is a horizontal line. So whenever it is horizontal, you label it as x. Any horizontal movement is described as x. So this means my R is a simple x. So to define R, you see your graph is very important and the axis there is important. So I'm just putting an x there. So that's my simple R. Then I can now substitute the rest just like before. -3 to 1 times. Then I have my x. Y1 square minus Y2 square. I did all the job when I was calculating volume until I arrived where we got 45 minus 24x minus 22x squared plus x to the power 40x. So I don't need to start all over again because I had done y1 square minus y2 squared when I was calculating volume. So I'll just open the bracket here and allow x to go through. I'll get 45x minus 24x squared minus 22x cubed plus x to the power 5. So that is the integral I have to do, which if I do this, I will then get 45 over 2x squared minus 8x cubed, because it's negative 24x over 3. That gives me negative 8 minus 22 over 4x to the power 4, then plus 1 over 6x to the power 6, from negative 3 to 1. So I can now substitute my limit. The upper limit is a 1, so I'll get 45 over 2 minus 8 minus 22 over 4 plus 1 over 6. Then the lower limit is the one that will give me a challenge. So I have to replace every x by -3. So I get -3 squared minus 8 into -3 cubed minus 22 over 4 into -3 to the power 4 plus 1 over 6 into -3 to the power 6. So this is now what we have to put into our calculator, which if we do that, we are going to get negative 256 and 3 pi. So that is our volume moment, u to the power 4, if you are interested in the unit. So you just need to take your time, substitute this into the calculator, then we will get our volume moment. And you can now calculate the x ordinate of the center of gravity. So the x ordinate of center of gravity is simply volume moment about y divided by the volume. So our volume moment about y, we see it as negative 256 on 3 pi. Then we divide it by our volume. Our volume was 1792 on 15 pi. So that is it. So if you do this division, we are going to end up with negative 5.7 as our answer, which in decimals is negative 0.714 units. And for you to know that this is okay, you can see it's negative. For you to know that this is okay, you must go back to your diagram and check along the x-axis where is the shaded portion situated. So that number, negative 0.714, must be within where the shaded portion is situated for us to confirm that's okay. So back on our diagram, you see that the shaded portion was from negative 3 to 1. And the majority of it is on the left side. So the center of this shaded portion is supposed to fall in the second quadrant. since the majority of the shaded portion lies in the second quadrant. So we've got around negative 0.7, which is making sense that the center of gravity of that shaded portion should follow. So, guys, thank you very much.